This video is about the unit of energy called the Electronvolt, and it's a unit that we use quite a lot in the photoelectric effect because it's a more useful unit than the joule, and we'll explain where that unit comes from and why it's better than the joule for some instances. Now, the basis of this unit depends on your understanding of the volt. Now, something I ask you about all the time: what do we mean by volt? Potential difference. Well, remember, a volt, or potential difference of 1 volt, means work done per unit charge. Okay, energy per coulomb, joules per coulomb. So if you measure the potential difference or the voltage across a bulb, it tells you how much energy is transferred per coulomb of charge as the charge flows through the bulb. If you measure the voltage of a power supply, for example, it's just telling you how much energy is given to each coulomb of charge to help get it around the circuit. So we can rearrange this equation that we use to define potential difference or voltage just to make work done or energy the subject. So if I know the charge and I know the potential difference that the charge has moved through, I can multiply the charge by the potential difference and it'll tell me the work done or the energy transferred. We're going to use this relationship between energy, charge and voltage to introduce this new unit of energy, the electron volt. So imagine we had two metal plates like that connected to a power supply. This one's connected to earth, so it's essentially 0 volts, and this one is at 1 volt. Now imagine we could just get one electron with a very, very thin, tiny little pair of electron tweezers, and we drop it in the middle of that area there in between the plates. We can't do that, obviously, but imagine we could just pop one electron in there. What's going to happen to that electron? Now, you should, of course, remember that the electron is negatively charged, so it's going to be attracted towards this plate here because this plate is more positive than that. It's a potential difference of 1 volt between the plates. So it's going to get attracted to that plate with a force, and it's going to accelerate towards that plate, towards the 1 volt plate. And when it gets there, of course, it's got kinetic energy. It started at 0, it's accelerated up, it's gained energy, it's gained kinetic energy. Well, how much kinetic energy has it actually gained? Well, if we go back to our little relationship we had earlier, the energy transferred is Q times V. Well, it's an electron, so charge on that electron is 1.6 times 10 to the minus 19, and it's passed through 1 volt, so times 1. So the energy transferred there is 1.6 times 10 to the minus 19 joules. And that's how we define this new unit of energy, the electron volt. It's equal to 1.6 times 10 to the minus 19 joules. Alright, so it's basically equivalent to the energy transferred when we accelerate an electron through a potential difference of 1 volt. You might say, so what? What's the point of that? Why do we need to bother with a new unit of energy? Well, of course, this number here is very small. 1.6 times 10 to the minus 19 joules is not a lot. This is a much more manageable unit of energy, the electron volt, because it's just 1. And you should remember that in your photoelectric effect calculations, a lot of the energies you were getting for the photons and the photoelectrons, the electrons that were emitted, were round about in this region. So instead of getting lots of tiny numbers in joules, 10 to the minus 19, 10 to the minus 20, 10 to the minus 21, you get numbers like 2.3 electron volts or something like that, not lots of tiny numbers with powers of 10. So you'll need to be able to get from joules to electron volts and vice versa very easily. So if you're in joules and you want to get to electron volts, what do we do? Well, the number we need to work with is obviously 1.6 times 10 to the minus 19. So what we need to do in this case is divide by 1.6 times 10 to the minus 19. Remember, 1.6 to the minus 9 times 10 to the minus 19 is a very small number, much less than 1. So we need to divide by that very, very small number to give us our bigger, more manageable number in electron volts. Okay. Conversely, if we're in electron volts and we want to get to joules, Okay, we can see up here 1 electron volt is 1.6 times 10 to the minus 19 joules, so we would multiply by 1.6 times 10 to the minus 19. Okay, so if I had 2 electron volts and I needed that in joules, I can pretty much see from the top what the answer is going to be, but if I multiply 2 by 1.6 times 10 to the minus 19, I'm just going to obviously get 3.2 times 10 to the minus 19 joules. Okay, so these little conversions here are very important. You need to be able to get from joules to electron volts and vice versa very, very easily.